talked about, so just we want to have some kind of webinar aspects. So let me float those points, some of the aspects which are very important. So basically I am giving supervised learning and just examples. Okay, anyone can opt, and if you are telling your name, then I can fix. Second is unsupervised learning. Some kind of examples. Third one, you need to talk about the regression and assumptions in regression. So these three things, you can give me the names, friends, so that we can first give the space for them. Just you need to some of the instructions like 10 minutes. Maybe you can create the presentation or some kind of document or whichever, which is a kind of revision, friends, actually, rather than me revision. So just you can go and collect some data. Even you can make use of whatever the class shell I have shared with you along with the note on the algorithms. Okay, just you can have a look on that. Okay, so supervised learning, who is
This is today or tomorrow?
no. Tomorrow onwards we'll start, Suresh. Okay.
Okay. I'll go with a regression.
Regression and assumptions. Okay.
No.
Suresh. Venkat.
Venkat should go with supervised learning.
You are supervising. No, actually, Venkat is going to opt this assumptions basically, but you already you reserved that.
I'll do one thing. I'll talk about regression. Let him talk about assumptions. We'll both talk.
Okay. Okay. Which
Is
one?
it okay? I'll talk about regression. You talk about assumptions.
Assumptions. that's unfair. Okay, that's good.
Or else let Suresh is taking complete regression and assumptions in regression. You can opt supervised or unsupervised, Venkat. That is your
We'll
wish.
take unsupervised.
Unsupervised, Venkat.
But we'll pick on Wednesday, Wednesday from Wednesday.
Yeah. Maybe tomorrow. Yeah. Tomorrow Suresh is going to take. So then, thereafter, maybe let us see who are all in the call. Yogesh is there, na? Yogesh, are you okay to take supervised learning? Just simple 10 minutes. If you're okay, means we can fix. Otherwise, we'll. No problem. Maybe he's in travel or something. Okay, no problem. So as of now, tomorrow Suresh is going to talk about this regression analysis and assumptions, and Venkat is going to talk unsupervised learning examples. Okay, and let them, other people are there, na? Lakshmi and Neelima and all. So let them join the call, and then we'll at the time of key takeaways we'll ask once more. Okay, then we'll see the how best we can do. Okay, now we are in the probability and stats 8th session, friends, and this particular thing I am going to discuss about the probability distributions. If you see in the earlier sessions, we have seen some of the aspects related to the probability distribution. Can someone quickly give a glance of that, friends? Which are the things we have seen? Discrete, continuous. These 2 points we have discussed. And if you are referencing the random variable also we have seen. Because there, if you are talking about the probability values, there is a small differentiation actually. So coming to the probability and as well as the probability distribution. Distribution, as the name implies, is
Distribution
a
gives the full idea of it
full
gives
idea,
total picture of it.
is a table or some kind of the expression. You know, there as an example, we have seen some cumulative probability also. So like, you know, rather talking about a particular situation, you can have a look on so how the accumulation can happen and how we are going to perform the activities. Okay, those things you can easily observe related to the cumulative. And thereafter we have seen some other things like, you know, expectation, that is mean, and variance kind of the aspects we have observed while talking about the probability distributions. Now the topic here is so if I am referencing the probability distribution functions, they are distinct. Like, you know, if you are referencing the types of distribution as mentioned earlier, we are having two things. First is the discrete. Okay, so discrete distribution. What do you mean by discrete, friends? By the way, how can you give the kind of characteristics related to the distribution? Discrete. Basically, they are categorical. Basically, they are categorical, and they are having some kind of countable or finite number of the possibilities. So they are finite in nature. These two things we have observed. Now, as a part of this discrete distribution, we are having Bernoulli distribution. This is the first probability distribution we are going to discuss. And second is the binomial distribution. Second is the binomial distribution. Similarly, we are having the second category as continuous distribution. Continuous distribution. Okay, so within this continuous distribution, again, we are having two aspects. The very first one is the uniform distribution, and second aspect is normal distribution. Okay, don't get confused, friend. Discrete is a kind of the data which we are going to work. Maybe that is a categorical or a finite. Can someone help me to give the example to understand the example of categorical, by the way? Categorical data.
Categorical is like your gender,
Gender,
or
blood group.
blood group, or
All these
your clothes, your small, large, or
yeah,
Just,
t-shirt sizes and all. Okay.
Just equal importance can be ranked. That's all.
Yeah, equal importance can be there, and there is a possibility of counting them, and finite aspects are there with respect to the categorical. Okay. And in the discussion of these discrete, friends, we are having two probability distribution functions. They are Bernoulli distribution, and second one is the binomial distribution. And continuous distribution, if I am talking, basically these continuous values, maybe infinite kind of the values, and there is a numerical kind of the data. All these things can be known as continuous, and in that case we're having the uniform and as well as the normal distribution. Okay, now let us start the discussion with Bernoulli's distribution, okay, which is the most commonly used kind of the distribution in the probability. Okay, so Bernoulli's distribution. So whenever if I'm saying Bernoulli, you should refer this is belongs to the discrete. Discrete meaning to say is a categorical kind of the data. Like that. Okay, so after some time you may not refer whether I'm working with a discrete or whatever the kind of thing, but just by seeing the distribution you should be able to tell whether I'm following the normal distribution, uniform distribution, Bernoulli distribution, or binomial distribution. By the end of the session you are able to observe these different categories of the distributions. And coming to the Bernoulli, friends, here, so let us understand this particular thing in a simplest way. A Bernoulli distribution has only one has only two outcomes, friends, namely success and as well as the failure, and a single trial. Most importantly, just if I'm giving a try, the outcome of that particular try is either success or failure. That's all. So such kind of the distribution I can name as a Bernoulli. Okay, so friends, here after talking about the probability or random variable probability distributions, all these things, now the things become easier for us, because earlier days, if I'm not introducing you what exactly the probability, what do you mean by random variable, and how we are seeing the probability distribution, maybe if I am directly introducing you the concept of the Bernoulli, you may feel a strange or something different. Okay, but whereas after walking through some kind of narration related to the probability, definitely you can get the fair understanding of this thing. Okay, let me put it in this way. So a Bernoulli distribution a Bernoulli distribution has only two outcomes. Has only two outcomes, namely success. For success, what is the number we generally refer, friends, in probability? Probability of success is 1. Probability of success is referred as 1, and failure 0, because we pretty know that. Okay, and these particular 0 and 1 are related to a single trial. Okay, single trial means just we are performing some activity, so that particular, as a result of that activity, we are getting either success or failure kind of aspects. And this kind of distribution I can name as probability distribution belongs to the Bernoulli. Now you see here, friend, just I'm trying to give some equation. Probability of success is always referred as P. Okay, and can someone help me how to frame the failure in terms of P? In terms of P.
1 minus P.
Very good. Okay, 1 minus P. Or else you can simply refer as Q. Friends, sometimes, you know, in some of the blogs and books, if you are following the probability understanding of this Bernoulli distribution, generally they either give P for the success or 1 minus P, or instead of that 1 minus P, they can go with Q also. Okay, don't get confused. Both are one and the same. Okay, the Q is something like, you know, which is opposite or alternative to P, which is a failure. Or else if you want to mention your Bernoulli distribution in terms of P, just you can have a look of success equal to P, and as well as the failure equal to 1 minus P kind of thing. Now, as I am talking about the Bernoulli, and that too I am talking about the discrete distribution, what is the kind of probability function I am having? Whether probability mass function or probability density function I am having?
It's a mass function.
Mass function. Why?
Density function is for your continuous, because there are a lot of values.
Lot of values. Yeah, the countable. Na? That is what we are putting the probability mass function. Is a probability mass function. That's it. Very good, friends. Probability mass function. As I'm talking about the categorical kind of the data, I'm having some kind of the categories related to that particular category. I can go ahead with the probability mass function. Now, if you observe the mass function like this, P of X is equal to, if X equal to 0, that means 1 minus P. If your X value is 0, that means failure, or else if it is P, if your X value is 1, that's all. Okay, very simple. So Bernoulli is not that much complex, friends, which is very straightforward, and which is giving you the kind of logic like if X equal to 1, that means success, then I can say the probability value as P. If my value is 0, that means failure, I can give the 1 minus P. And suppose if I am writing this particular thing in this possibility, friends, have a look on this. P power X into 1 minus P whole power 1 minus X, where X is belonging to 0, 1. if you observe, can someone help me to understand this equation also, because this is a alternative method of writing the same, but how do you achieve that particular thing? Just to think through, both the equations are in front of you, and if I'm asking you to justify this thing, how do you feel that? Suppose if you are putting 0,
We have only two values possible in Bernoulli. One is success or failure. So if we put x is equal to 0, that means it's equal to 1. That is
yeah, p power 0 into 1 minus p. Okay,
minus p.
that is all. If x
That is
equal to 0
1
means
minus p.
1 minus p only. Suppose if you are putting
X is equal to 0 is failure.
p power 1 minus p whole power 1 minus 1. That means p power 1 into 1 minus p whole power 0, which is p. So obviously, friends, here, if you are making use of your x as 0, you end up with 1 minus p. If you are putting your x as 1, you end up with your p. So that is how you better you see based on your mindset. Maybe you can remember. To be frank, you need not remember also, because we just see the understanding of the diagrams only, maybe after generation of or after observing some our data, and you can easily, you need to observe whether the kind of probability and how we are getting into success or failure. Now I'm having some kind of example for you. So suppose I'm having the example like this. I want to set a debate in technology with Satya Nadella and some XYZ person who is a layman in technology. Somehow, okay, anything can happen in life. So somehow this Satya Nadella catch hold of this XYZ person. And can someone help me, friends? What is the probability of success of this person to defend Satya Nadella in technology?
0.
Okay, like that. So very less, maybe 0 also. And if I'm talking about the probability of failure, okay, maybe 0.999, like that it goes on. Okay, so what is your understanding from this? This is definitely a best example for the Bernoulli. What do you observe? Maybe if you are talking about higher change, that's fine perfectly, but what is your other option of seeing this Bernoulli distribution? Do you think there is a chance of getting equally likely, that is 50% success, 50% failure, or is there any typical understanding is there, friends, in the Bernoulli? Can we do that? Because either 0 or 1, and if I am clearly mentioning that 50% of chances are there, 50 are there, it's not like that, friend. They are not equally likely. Actually, there is no dependency also. So just there is a chance of getting 1%.
It is a gunshot. It is a gunshot. Either it should be a 0 or it should be a 1.
That's it.
So he should be a successor or it should be a failure.
Failure 1. Okay, right. That is perfectly all right. Now, suppose if I'm, maybe you want to get some, because all our aim is to go and verify the kind of the data, the format of the data, appearance of that particular data related to this particular distribution. If I am giving you this example, friends, just have a look on this. Let me pull the diagram for you. So if I'm making use of this diagram, just to have a look on this. Okay, just you see here the probability of success and as well as the probability of failure. Definitely it is a Bernoulli distribution. Okay, there is a clear distinction actually. So it is saying that chances are 0.15% for the success, and there is a chance of failure for 0.85. Okay, this is how you can refer your Bernoulli distribution. Now, just to go back and think through, I have given some a mean, which is expectation of X, and as well as some kind of the variance of X I have given. Okay, now you observe here, friends. Which one can I take as a mean, by the way? Expectation of X. Is a p value, friends. Expectation of X equal to p. That's all. Probability of happening or the reference. Whereas if I'm talking about the v of X, what is the formula, friends? That day we have seen e power e of X square minus e of X whole square kind of thing. Okay, now if you observe, this I am taking as a p, maybe that is a success or failure kind of thing, and I am putting this as, if I am putting p of X, e of X as p minus p minus p whole square. If I am referencing this thing, if I am writing these things, what is your observation, friends, from variance? Variance of the Bernoulli is giving that the success and as well
Success
as
and
the
failure both.
failure, both the combination. Okay, just
That should not.
see the important point here, friends. In case of the probability, the mean value and variance value, we have seen some kind of the equation format. In the earlier examples also, we have worked upon some of the examples. If you go and see the earlier recording, or else you would have prepared earlier also. Okay, so maybe the thing is distinct, but for every probability distribution which we are talking, there is a distinct way of computing this mean and as well as the variance. Okay, so if I am referencing the kind of p and as well as the 1 minus p kind of the values, then their combination of p and 1 minus p can be same as variance. What do you mean by variance, friends, by the way?
Difference from the mean.
Different from the mean, and which is used to identify how each value is distinct from the group of values or set of values. Okay, so that is how you can refer. Now if I am talking about the uniform distribution, okay, just to have a look on this, friends. Uniform distribution, whether uniform distribution belongs to discrete or continuous. In the above example we have seen, just I want to give you the continuity of uniform distribution, which is a continuous distribution. Okay, rather discrete, this is a continuous distribution because some aspects are common in both Bernoulli and as well as the uniform. That's what I pull this thing. And you see here, what do you mean by uniform, friend? Generally, uniform behavior.
Steady values.
Study values and equally likely, because you know, in case
Equally.
of the in case of the Bernoulli, we are not guaranteed that they are equally likely chances. But at the moment, friends, if you see the uniform distribution, so just to remember, this is a continuous belonging. Okay, right? And one more important thing is this particular continuous belonging. What it does is the probabilities. Okay, so the probabilities of getting, okay, the probability of getting outcomes are equally likely. Okay, equally likely, and that is the basis. Okay, which is you can observe in the uniform distribution. So let us see with some example. See, friends, what is the observation in case of the Bernoulli? Can we have number of possible outcomes, friends, in Bernoulli? What is the limitation of the Bernoulli distribution?
It is either
0 and 1.
0 or 1 and single trial, friend. This you have to have a look on this. It is a single trial method, and maybe we are getting success or failure. And one more thing is they are not equally likely. See, I cannot say that the possibility of success and failure are dependent or something like that. It is not there. The Bernoulli is like that. If that is the case, then we can say that as a Bernoulli. Otherwise, in a other way, you can say that. Suppose if you are performing some activity or trial, that is, you are allowed to perform only one trial. Maybe Amazon or some kind of the companies are there, na PayPal and all, they allow us only one time for the interview in the span of 6 months or 1 year. I don't know whether other companies are having or not. Generally, they put one constraint: up to 6 months you are not allowed to perform. That is a single trial method. That is definitely a Bernoulli. And even you are attempting a single, maybe success or failure is also completely, if they're having 7 rounds of interview, okay, and they ask all the products information about Amazon. You need not have other technologies also. And even I observed one more thing, friends, in Pegasus also, you know, they're having their own platform, friends, that project management platform and all. You know, they don't worry about whether we are having Python or Scala kind of the background or efficiency. Only they need your object oriented skills, maybe inheritance or little bit SQL. So they touch base on that, and after joining within the 3 months you have to clear some certification, and then you can go ahead and perform your activities. So these are all belonging to the category of the Bernoulli's distribution. Reason behind this is single trial, maybe the success or failure is completely independent. Okay, they are not equally likely. There are chances of getting success or failure kind of thing. Whereas uniform distribution, there is a distinction. As first I mentioned, you know, they are equally likely, so there is a chance of getting success or failure in a dependent mode. And one more important thing is there can be n number of possible outcomes. Okay, there can be n number of, I will explain with some example, a number of possible outcomes. Now, if I'm saying this thing, as I'm talking about the continuous probability distribution function, whether it is probability mass or probability distribution. Continuous. Probability mass or probability density?
Probability density.
Density function.
Density.
Probability density function. Now, just observe here, f of x equal to 1 by b minus. If you remember, friends, in the earlier example, we use it to refer the infinity to infinity, because this is a continuous kind of thing, na? So for minus infinity, a is less than or equal to x, less than or equal to b, and up to the infinity. That means a b values are here the parameters, you know. So a and b values are parameters, and in between -1 to infinity, any value can be taken. B values are parameters. Okay, and maybe still you are getting some kind of ambiguity. Let me solve this problem, friends. Okay, I'm giving some example here. So the example is like this, friends. There is some kind of bookshelf or bookshop, online bookstore or something like that, which is rare books, friends. Only they sell only the particular books and old books. Now their observation here is, you know, so the problem statement is like this. This particular uniform distribution helps us to understand that particular problem. Okay, the number of books sold daily at a particular bookshop is uniformly distributed with a maximum of 40 and minimum of 10. Okay, so maximum of 40 books they sold, and minimum of how many books, friend? 10 books. Maximum of 40 and as well as the minimum of 10 books. Okay, now our interest is calculate the probability that the daily sales will fall between 15 and 30. Okay, what should we calculate? Calculate the probability that daily sales fall between 15 and 30. Think through this example, friends, and how do you refer this problem?
Your x value will be 15 and 30, where a and b will be 10 and 30.
Very good. Okay, 1 by b minus a, and here we are having this thing na, into expectation, the probability values na. So this particular probability, I am saying maximum value, I want to get the maximum between 15 and 30. Na? This is the minimum value. Simple formula, that's all. Okay, so now observe here, what is your B, friends? 40 from this maximum books. And what is our A parameter? 10. 1 by 40 minus 10 into, what is the thing we have to compute? 15 and 30 between, we have to calculate the
30 minus
probability. Okay, so that means 30 minus 15. This is our expectation.
1 by
Now,
2.
if you observe, yeah, you can clearly say that this is of course
1 by 2.
15 by 30, which implies 1 by 2, that is
0.5.
50%. This is nothing but the equally likely. There are certain chances of getting the books equally likely. Now, if I am asking you, you have to tell this answer, friends. If I am asking you like this, I am not giving any kind of 15 to 20. Just you think through. There is a little bit tricky. The question is, if I want to get daily sales greater than or equal to 20 books. Now we are having other thing, maximum 40 and minimum 10 we are having. Along with that, they asked us to compute the daily sales greater than or equal to 20. How do you do that, friends? Any thought, Venkat or Yogesh, Suresh? This remains same. This is
So
okay.
B will be 20. The maximum value will be 20. Minimum value will be 0.
Just to observe that greater than or equal to 20,
No,
we are asking.
Minus
Greater than
20. 40
Okay.
minus 20.
Excellent. How do you say that? What is the basis for that?
No, because they say the maximum is 40.
So minimum sale is 20 per day. So maximum sale would be 40. It's
40.
already given.
That's all.
Yeah, the
That's
minimum
all.
sale is also given.
40 minus 20.
40 minus 20. Hope you got the point, friend. Maybe, see, this is the way you need to think through. In some cases, we may not get the complete values, but still, there is some reasoning would be there, because greater than or equal to 20, up to what extent we have gone? 40 only. So though they are not giving, we are having the chance of implementing this thing. And however, we know this 20, for this 20 we have to calculate 20 by 30, which is of course 2 by 3. Okay, so this is how you can refer the uniform distribution. Can someone comment on now, friends, what is the point, or which are all the points you have observed between uniform and Bernoulli distribution? Because practically you need not implement 1 by B minus A into something, all these things. Directly by seeing the diagram, you have to tell. Okay, let me pull the diagram. In meantime,
Bernoulli will give only either a 0 or 1. There is no any middle values which it is giving. But this one gives you the middle values, how much it is proceeding.
Okay.
Both of them shift between maximum and minus. So this also works on maximum and min.
Yeah, this works. Yeah. Any other? That it belongs to the discrete, and this is belongs to the continuous. Apart from that, any other observation you have made, friends? Or else let me put the point in this way. What is your mean here? Just to think through. What is your mean and what is your variance here? You know the answer. Probably if you go through this, even by seeing this diagram also, you can say what is the mean of this thing. Mean or average or whatever. Friends, can I write like this?
A plus B by 2.
Okay. Can I write variance as like this, friends? What is the variance actually? Just I am having B value and as well as A. Can I do like this, friend? B minus A whole square by 2. Okay, so that means here, if you observe in the Bernoulli, we are having expectation of X equal to P. What is the variance of X, friends?
1 minus
P into 1 minus P. So that means there is no standardization in the distribution, friend. That point you have to observe. If it is Bernoulli, the mean is P and variance is P into 1 minus P. If your probability distribution is uniform, then your mean is completely depending on the formula, friends, nothing else. Because in our Bernoulli, we are having equal to P and equal to 1 minus P. Okay, that's how we have taken this particular P value. Okay, so whereas if we are talking about the kind of values, whereas variance, there we have seen P into 1 minus P. There the equation holds good in the distribution. Whereas if I'm talking about the uniform distribution, there is a slight differentiation as we are talking about the maximum and as well as the minimum value. That too in terms of the parameters, 1 by B minus A, which is your A and B are running through some kind of the model. Okay, this is also known as something like, rectangular distribution. Because this is looking like the rectangular kind of the shape. So you can say that as a rectangular.
I want some other.
Oh, okay. Carry on.
Yeah, sorry guys, some network issue. Yeah. 1 minute. Hope you are seeing and hearing me. Seeing the screen and hearing me.
Yeah.
Okay, friends, sorry for that. And see, based on there is no standard mean and as well as the variance for all the distributions, because distribution itself, the word itself is saying that we are working on various values. Okay, and now if I am referencing the Bernoulli, the corresponding mean value and the corresponding distribution value I have observed. Now I am introducing you one more aspect, friend, which is nothing
So
but
practically, where do you put Bernoulli practically?
practically
When you are making a model.
Bernoulli we can use in a single trial method. It all depends on the problem statement. Na? So maybe you're taking the recruitment process of the Amazon or recruitment process of the Facebook or Google, only one time chance. And that too, if you see the any entrance examinations also, if I'm having only one chance, okay, maybe sometimes TCS also in the recruitment process they clearly says that no, there should be no backlog and the person should clear the engineering subject at a go. So that is what Bernoulli, friends.
Okay.
Okay. So like scenarios, maybe they are having the scenarios like only 2 options and 1 trial. You have to remember that there is no scenario at all, friends. That is what actually that is a good point. Good to raise because there is no scenario and there is no situation, because situation in the sense there are some circumstances and there are some multiple possibilities. Can we really have
I think
any?
I think Umar, these are the added ones which comes inside when you are evaluating.
Exactly. So there is no dependency
So
and there is no.
Yeah, like you can't make it a proper this thing. Actually, you should be adding somewhere else in between in a conditional way, where okay, this particular Amazon, he's going with this process, and he's going only. We have to use only the Bernoulli.
No, not like that. No direct implication. Only the thing is, Suresh, see, in your team, stat experts would be there, but you should not become one layman or admin out while discussing these points. Suddenly, if he says maybe your case study is following uniform distribution, then you should connect the dots. Yeah, I have seen 1 by B minus A kind of thing, at least, or else by seeing this particular rectangular kind of the shape after displaying your graph, or else, just by seeing this kind of the graphical representation between failure and success. If suddenly your subject matter expert that statistical guy directly pull this Bernoulli in the discussion, you should talk something. Yeah, you can see success and failure.
The scenario. I should talk about the
no need. Only the thing is we need to exactly. And why I am covering these things is maybe nowadays in the interview panel also they are keeping one statistician, friends, in the third or fourth or second round of interview. Just they need to touch base on this. Even in Mindtree and all the other areas, if you talk, generally they are expecting like what exactly, maybe they are not asking you to write something formula or something, but can you give the Bernoulli scenario or uniform distribution like that? Okay, so that you can, with this idea and with this preparation, you can easily think through and break the barrier of this stat. Okay, that's what.
So one big thing, what you told is it's a classification data. Classification is always like yes or no. So null is definitely it has this result yes or no
Maybe,
kind
yeah,
of.
yeah, exactly, correct. And that too, if we are talking about the regression, friends, though your probability, as our Venkat said, in classification, one more statistical test I am going to introduce for you, like chi-square test. Directly, we are making use of that chi-square in the generation of the decision trees, friends. Okay, so though our statistical reference is strongly associated with the regression topic, maybe that is a single or multiple regression or logistic regression. Can someone quickly help me to observe which is the statistical methodology we are using in the simple regression and multiple regression? 2 or 3 days back, we have covered these aspects actually. What exactly regression is saying, friends? Suppose if I'm drawing like this, what exactly this regression is saying? One word we have used actually. We discussed some aspects. Excellent. Very good, Venkat. You are very good. See, regression establish a kind of the correlation between the dependent and as well as the independent variables. Okay, maybe in simple regression, dependent variable is one and independent variable is also one. In case of your multiple regression, dependent is one and your independent variables may be multiple. Okay, so it is a kind of correlation establishment. Similarly, if I am saying chi-square test, I'll introduce friends after maybe tomorrow's session. I am pulling all these Z score and t-test, f-score test, chi-square. Okay, just will see walk through what exactly these terms and terminologies and how they are related with our machine learning algorithms. Okay, this chi-square has a direct implication of this decision tree, because in the generation in the population of the tree, just you can make use of this chi-square as a kind of the measure and as a kind of the parameter to discuss the decision tree population. Okay, in the same grounds, we are having the binomial distribution, which is commonly used thing, friends. Maybe you can give the scenario at a later point of time. And this particular binomial distribution again is a discrete. Okay, it's a discrete method. Now if I am saying like this, a series of Bernoulli. That means your binomial distribution is a series of Bernoulli. And if you are talking about the distribution where only two outcomes, yeah, it remains same. Only two outcomes I am having. And one more important thing is, of course, possibility of success or failure that remains same, 1 or 0. But where the probability of success and failure is same for all trials is called the binomial distribution. Okay, so that means how many trials we're having, friends? Success or failure is same for all trials. All trials is called binomial distribution. Simple, friends. Here success failure remains same as that of our Bernoulli, but this binomial is giving a chance of getting into multiple trials. Okay, I'll give you the example. Now before that, let us focus on some kind of the properties. If I'm referencing the properties related to this binomial. Okay, how many possibilities are there, friends? Outcomes? Only two possible outcomes. What is the outcome? Which are all the two possibilities? Success or failure?
No
Okay,
failure.
that's all.
0 or 1.
0 or 1. Second thing is, see the difference you can observe here. N number of identical trials. What do you mean by this, friends?
How can it be identical trials?
Yeah, definitely. It is there. I'll tell you. Okay.
yeah, yeah.
And the third important point is each trial is independent of the others. Each trial is independent of the others. Suppose a classical example. Suppose a person is attempting some engineering semester examination or some MTech or some kind of PhD entrance examination. How many trials he can give, friends? If it is engineering, maybe he's having 8 years span. If it is MTech, he would be having some 4 years, double the years. And if it is PhD means we are not considering entrance, but we are considering only submission of thesis, something like that. Maybe he is having some 8 years. Now you see, what is the outcome, friends, here? Basically, what is the outcome? Maybe 8-year span or 4-year span, success or failure. Maybe he can pass or maybe fail. Other than that, any in between case is there? In between pass and fail, can he get any other outcome? Because the same trial he is giving, but one trial is independent of other, because if he is pass also, he cannot give the exam. No? He has passed that exam. Again, he cannot go back and say, I want to take this exam once more. No, such kind of betterments are there. Assume that is also one condition here. Now the point here is, friends, so even though he is taking the same trial, but each trial is independent. If he is pass means he need not take the second trial. If he is failed means he can take the next trial. Okay, based on that particular convention. Now, if you are referencing this example, just have a look on this. One more example I will give. Just if you are referencing this particular binomial distribution, friends, I am making use of this equation like this, or else let me copy from the net. What is the binomial? Yes, binomial formula. Okay. Whether binomial is having probability distribution or probability mass or probability density?
Mass.
Mass. Why?
It's a classification, discrete.
Okay. Categorical.
Categorical.
Okay. Already Venkat has gone into machine learning mode, friends. He's saying classification. Very good. So P of x equal to n factorial by n minus x whole factorial into x factorial. Now what is this P value, friends? P is success and our Q is failure. Okay.
No,
Q is failure. Rather than 1 minus P, we are taking this success and failure. Now you observe here. You know this particular example pretty well, friends. The example is like this. Suppose I am flipping a coin. So just I am flipping a coin. Flipping a coin, can I take as a binomial or Bernoulli?
Bernoulli.
Suppose if I am taking flipping 2 coins. Now I can say binomial. Okay. The standpoint is binomial. Okay. Just we'll see the binomial now as we're discussing that. Now my intention is just to let me see the possible outcomes. Can someone help me, friends, to register the possible outcomes? Flipping 2 coins.
Both
head
or tail.
Both head trail.
Trail head.
Okay, so these are all the possibilities. Now if I'm talking about the x, the number of heads has a result from the experiment. Now if you are referencing this 0 outcome, friends, getting the 0 heads, getting the 1 head, getting the 2 heads. Now in the earlier example, if you remember, can someone recollect, friends, in the probability specification of getting 0 heads means what is the outcome here? Total is 4. How many heads we are getting? 0 heads? One possibility, na? One possibility, 1 by 4. Okay, what is the value here? 0.25. Now getting the two heads means, friends, how many, what is the total outcomes are 4. And here we are getting two heads. So that is 1 by 2, which is 0.5. And getting two heads, friends, here, total 4. Two heads, only one chance, na? 1, which is nothing but 0.25. Okay. So you may ask me, what is the relation between these two? Now there is a equation is there now. Let me write the equation here. P of x equal to, what is the equation, friends? Or else
N
let me,
factorial.
yeah, let me copy and we'll make use of that equation here also. Now just observe here, friends. I want to verify the getting of the zero heads. Okay. Now what is the n value, friends, here? Number of trials. How many trials we have? 1 or 2? Number of trials.
T and T, two well, two.
Because binomial, na? Not Bernoulli. Bernoulli is definitely 1. Definitely 1. What is the x value, friends? X value running between 0, 1, 2. Getting 0 head, getting 1 head, and getting 2 head. Okay. Now what is your p value, friends?
P value is 1.
1 or 1 by 2?
Okay, again I'm getting confused. Okay.
Yeah, no problem. Okay, let it be. Later we'll talk. Now, if I'm substituting this value, friends, here, what is the n value here? 2 factorial by 2 minus, what is your initial x? 0 factorial. What is your 0 factorial here? What is your p value, friends? Basically, assume that this is a equally likely, because tossing a coin is definitely equally likely event, na? Is continuously following the same approach. We are taking this particular thing as 0.5. What is the x value, friends, here? 0. What is your q value? What is your n? 2 minus 0. Can you compute what is the value, friends, here? 2 factorial means 2 factorial by 2 factorial. 0 factorial value is 1. However, 1 into, what is your 0.5 whole 0?
1.
1. And this one also?
0.4 square.
5 whole square. 0.5 whole square. 2 to get 0.25. What we have computed earlier for the 0 head? 1 by 4. This is also giving 0.25. See, friend, this is the normal probability of observing this one. Now the same thing we are getting with the binomial distribution also. Then what is your understanding? Okay, hold on that. Now we compute for P of x equal to 1 for the clarity. Okay, let us do that. P of x equal to 1. What is the formula here? For 1, suppose if it is 0, again, let me copy the equation to avoid the introspection problem. Now you substitute, friends, and tell me the answer. P of x equal to 1 is equal to, n value is, however, 2. Your n is 2 and 1 x is 1 factorial into 1 factorial. What is your p value? 0.5 whole power 1 and 0.5 whole power n minus x. Your n and 1. Now you observe here. So this 2 factorial by 1 into 1. Okay, so this is 0.5 into 0.5. 0.5 into 0.5. What is the value? 0.25. However, okay, so that is your 0.25. So this 2 factorial remains same, 2 into 0.25. What is the answer, friends?
0.5.
0.5. Now what is the outcome here we received? 0.5 for the normal probability. Okay, now give a try of probability of x equal to 2 also, so that we can have only one value with us, and just we are making use of our n is equal to 2 here. Our p value is also, our x value is also 2 here. Now at the moment I am selecting this one, 2 factorial by 2 minus 2 factorial into 2 factorial. And what is the p value? 0.5 whole square into 0.5. Your n value is 2 and x is also 2.
2 minus 2.
Okay, now you have a look on this, friends. Okay, so just you 2 factorial by 0 factorial into 2 factorial. This is 1 and 0.25. Okay, so here if you observe probability of x equal to 2, getting the value of 2 heads, 1/4, that is 0.25. The same thing you can recheck here also. Now the binomial distribution. Okay, so just whatever the formula we have taken, just to observe, friends. See, the probability here, only some of the members made that as complex, nothing else. Just by hearing the word probability, don't get we need not get any is not a alien kind of thing, or it is our it's not our aspect. Okay, that's how all other statisticians are running on the heads of the data scientists. Okay, so though data scientists are there, but still companies are preferring the statistical members to be a part of their subject matter expertise. Reason is because these data scientists and data engineers or machine learning engineers, and these are all not at all interested to learn these kind of the aspects, and they don't even want to go through these kind of the terminology. At the moment I'm talking about the probability distribution, no one would be there in my team. So as to discuss and talk, because they always interested in okay, if I'm talking about Scala or Spark or something algorithm regression and all, they are very happy. At the moment I start the discussion with probability distribution, then they disappear. So the reason behind it, they won't get that much comfortability or access with these kind of the technique. But believe me, they are all very easy, and you can easily go through these kind of the distribution center. Now with this knowledge, if I am asking you to give the mean value of this thing, can someone give a quick try, friends? How can you refer this mean or expectation of x related to the binomial distribution and variance of x? Now just to pull the aspect of in Bernoulli, if you remember, what is the E of x value, friends? P. What is the V of x value? P into 1 minus P. This is for one trial. This is for one trial. How many trials we're having for binomial? N trials. Now you think through, anything is coming into your mind? Just to think through, you can give the answer, friend. Very simple.
P of n.
Can you rephrase? P into n or P of n?
P into n. Yeah.
N, because see, this is one trial, so we got P. How many trials, such trials we're having? N. Similarly, can you give the variance, Venkat? Think through on the same lines. Same lines. This remains same. P into 1 minus P into N. That's all. Or else P, Q, N. Okay, because 1 minus P you can refer as Q. That much simple, friends. Okay, don't worry. Just by seeing this N and all, nothing. Because in Bernoulli, we are having only one trial. Whereas if I am talking about the binomial, I am having the N trials. Okay, so these kind of N trials are helping us so as to follow up, though we are getting the success or failure in the same for all the trials. But observe here, we are adding that particular N number of the trials. Okay, compared with the Bernoulli, binomial distribution is having some kind of the scopes towards. Okay, now can someone help me? What is the format of this binomial the distribution diagram? Because we have seen in case of the Bernoulli, we have seen some success and failure. There is no other way. There is a complete success or failure kind of aspects. What about our binomial? Any obligations or anything you want to add? How it look like? Because we're having multiple trials with us, and you can make use of the corresponding trials. And now for the same example, if I want you to draw the diagram, okay, just you see here, friends, number of heads 0 and number of heads 1, number of heads 2. So obviously the corresponding probability value you can observe. If you are drawing a kind of the graph, just you can observe the distribution or whatever the way you can have, because just it is a way of representing how many number of heads, 0 heads, 1 head, and as well as the two head. So just with the, by substituting a simple formula, we can easily identify the representation of how we are making use of the convention of Bernoulli and as well as the binomial. Okay, can you give a quick revision, friends? What do you mean by Bernoulli, uniform, and binomial? Bernoulli, first thing we have seen is Bernoulli.
It's a single trial.
Single trial, very good. That is the first point you have to remember. Either will be getting success or failure. That's all. There is no scenario, no nothing. Now we were talking about the binomial.
It's a series of Bernoulli.
Series of Bernoulli, which is the multiple trials.
Multiple trials.
Maybe you are having success for each and every trial. You are having the success or failure. How about this uniform distribution? If you are seeing the uniform is a bit distinct, because there we have seen some 1 by b minus a, such kind of the formula, and there are certain things we have seen. The probability of getting equally likely outcomes, they are not distinct. Okay, there can be a number of outcomes. It's not only success or failure. In between values also we can get. There we have seen some example, friends. Selling of the books. Okay, maybe maximum 40 and minimum 10 books. They are their regular sales, and we have worked on 50 and 30 books per day, and other example we have taken as if I want to implement, if I want to know how many books were sold in a particular day greater than or equal to 20. So in both the cases we have seen that particular the behavior. So how we are getting that, and especially in case of the Bernoulli, we are having p value as the mean and p into 1 minus p as the variance. What is in binomial, friends? In binomial, what is the mean value? N into p, because n number of trials we're having rather than one trial. And whereas if I'm talking about the variance, it is something like what is the variance value? N into p into q. Whereas in case of Bernoulli, we're having only pq kind of the things. And now I'm going to talk about, though if you are not remembering the above things, it is okay, friends. But now the fourth one, can you remember what is the fourth one we have to discuss? The fourth type of
Normal.
Very good. Okay, normal distribution. Majority of the times, friends. Okay, the type of the data we are following in this is continuous. If I am talking about the continuous, it is whether I am having the probability distribution, probability density, or probability mass. Density. Okay, probability density function. Now see here, friends, any distribution, suppose if you are asked to verify the distribution, you use a normal distribution, if it has some kind of the characteristics. Observe here, very important, friend, because I'm going to introduce one more important topic, friends, related to the normal distribution, so that I need your utmost attention, because understanding of the properties is important. Properties is very important in the normal distribution. So if I want to say any distribution as normal distribution, any distribution as normal distribution, if the distribution has the following characteristics. It has the following characteristics. Observe here, friends. So coming to the first property, most important property, that means you may be wondering, mean, median, and mode coincide. Mean, median, and mode coincide, and the curve, because we are seeing some curves now in case of uniform distribution, Bernoulli distribution, binomial distribution. The curve is bell-shaped. Curve is bell-shaped and symmetrical. And next important property is each half of the values around the center are equal. See friends, very I mean, most commonly used kind of the distribution in the landscape of our machine learning is a normal distribution. Okay, and because the properties, if you observe, maybe first time you may feel how can I get mean, median, and mode coincidence, and of course bell shape curve might be either bell shaped or symmetrical kind of thing. And the third important property is each half of the values around the center are equal. That means suppose if you are taking the axis values, if you are making use of this particular curve, and this is first off and second off kind of thing. Okay, all the negative values here, all the positive values here, equal distribution. Okay, so bell shaped curve and values are symmetric. And you know, here mean value, median value, and mode value more or less they are coincide. Okay, they are very nearer. Now the formula might be a bit distinct, friends, but you know, here the most important thing we have to observe is what is the mean value, friends? As directly I am getting the mean here, so that means here mu value is mean, and of course your variance is of course sigma square. Okay, you can refer this kind of thing, that is perfectly fine. Now, at the moment you are specifying the normal distribution, you should observe the mean value and as well as the standard deviation. So, if I want to work with the kind of the distribution related to the normal distribution, definitely I should have this specification of mean and as well as the standard deviation. And one more point I want to refer here, very important point, friends. Okay, so now you observe in case of the Bernoulli, and we are having some condition. In case of uniform, we are having some kind of the observation, and in case of the binomial, we have seen some kind of the observations. Rather than the observations, rather than the conditions, here we are getting the characteristics, friends. Actually, if you observe the versatility of this normal distribution compared with the other kind of the distributions is we are something like we are getting some kind of the observation, and that particular observation helps us to verify the mean value, median value, and as well as the mode. And of course the curve is definitely a bell shaped kind of the curve, and which is really giving us the inclination of understanding how the values are spread over in a particular distribution. Okay, now let me pull one diagram and just to give a understanding of this particular diagram, friends. Okay, what you have observed, spend some 1 minute of the time, definitely worthful, because our next discussion is completely revolving around this particular diagram only. Have a look on this. This particular diagram is trying to tell something. Okay, though those points I need from you, and which are all those particular points? What is your observation? Just take your time, no need to have any worry, because in case of the normal distribution, if your um, data set, after drawing your data set or after observing the kind of distribution, if you confirm that particular data set is following the kind of normal distribution, then these are all the points you need to bank on, and these things are very much helpful to think through what exactly your data and how you can make use of this particular data for the better understanding of the problem definition or scenario. is the very first point, friends? If you observe this diagram, friends, this is of course mean. This is the mean value. Then what do you mean by this one?
I think here mean the values are coming same. Like on when you see the standard deviations means the values will be, you have mean, median, mode values will be same.
Same. That is
in the
one.
normal distribution.
Okay. However, now can you elaborate the relationship between the mean and standard deviation? In front of you, the this diagram is there, and I have given a clue also just by writing some kind of the standard deviation. You can observe the kind of relativity between mean and standard deviation. Or else, let me put this question in this way. Your 68% of the data is between some region, and your 95% of the data in some kind of the region, your 99.7% of the data is in another region. Can you name those regions, friends, by the way? Okay, that means your 99.7% of the data is 3 standard deviations
Ranging from
distance.
-3 to 3.
Standard deviation.
Excellent. That means mu plus or minus 3 standard deviation. Hope you got the point, friends. Now you tell me this equation. 95% of the data is spread over to 2 standard deviation. That
Two
means
standard deviation and single standard deviation.
yes. Okay. And the third point, friends, actually 68% of your
When you're going
data.
with the percentage.
Yeah, percentage exactly. Because out of 100 records, your 99.7% of the records are in mu plus or minus 3 standard deviation, and your 95% of the records are in the range of mu plus or minus 2 standard deviation, and your 68% of the data is distributed over mu plus or minus 1 standard deviation. Okay. Now, if you observe here, friends, what is the benefit of logicking this thing?
You get a when you go with a 3 standard deviation, you have a perfect data. The data will be more precise data.
More
We
data
don't need
will
to
be
take
getting.
all data. We can take the data between that range.
Exactly. That is the see. Suppose if I want to get the kind of the data, it is always talking about the ranges, na? So that he going here and there. Rather, what I can say, if I'm having my mean, I'm having my standard deviation, and if they are putting me under this 92% of the data is enough, I can select mu plus or minus 2 standard deviation. I need not go with everything. Whereas if the people are happy with some 70% of the data, okay, I can simply go with 1 standard deviation. So that means here we are providing the possibility of mean and as well as the standard deviation in such a way that, so just we are making out of, okay, so whatever the number of standard deviations I'm having from my mean, so that I can make use of the convention mu plus or minus 3 standard deviation. My 99.7% of the data is revolving around the standard deviation. And one more question, friends. So here this is the -3 and this is +3. Now, if I'm making this statement, so between -3 and as well as the +3, I'm having my 99.7% of the data. Suppose if someone asks me to get only the right side portion from my normal distribution, how much percentage do I get, friends? This is the problem we are going to solve. So just if you are referencing, because I'm assume that this is a 3 standard deviation plus 3 standard deviation, right side means that one on the right side positive. Okay, so just I want to pick up only the right side thing. Okay, so if you are making use of that convention, friends, actually my interest here is I want to pick up only the right side portion of my whatever the mean and whatever the standard deviation I'm having. Okay, so just let me give you this example so that you can have the kind of understanding how we are going to refer the kind of the standard deviation and all. So I'm having some kind of the survey with me, friends. Okay, that particular survey, which is nothing but I have given some kind of training to my managers and all those members. Now I want to get some identification, which is understanding of whether these particular managers are got the proper or fair understanding of this particular thing, and I want to get the feedback from the managers. Feedback in the sense just the training was given to the senior managers and junior and mid-level managers. Okay, that is my interest, and I have conducted some kind of a training program, because nowadays all the companies are making use of this particular training, and they want to identify, okay, so whether this particular training is successful or not. How do they identify, friends? Just let me get this thing. Okay, just I'm pulling some case study for you guys. Use case. Some organization planning for some training for their employees. The average or mean of the training is 500 hours. The standard deviation is 100 hours. Okay, I mean to say that those is a self-learning kind of thing. They have put some 500 hours content, and plus or minus those 500 can be observed as the time taken by those particular managers so as to complete the course. Now, if I'm asking you guys, just observe here the question I asked you. The use case is pretty simple. So just you can refer this thing. So there is a training program the organization planned, and here my interest is what I want to get is just have a look on this, friends. What is the problem statement? What is the probability that a participant selected at random will require more than 500 hours to complete the training? Okay, that means I know my mean value equal to 500 hours, and standard deviation they have given as 100 hours. And next important thing is, friends, my requirement here is greater than or equal to 500 hours. More than 500 hours. And what is the probability that a participant selected at random will require more than 500 hours? That means suppose if manager is Suresh, and I have selected Suresh, and I want to get the probability of completing. Okay, so the training program greater than 500 hours. And just to think through, friends, no hurry, nothing. What is coming to your mind, just to observe that, and you can come out with your analysis. I have given some insight also. If you want me to put the diagram once more, definitely I can do that. So that means what is the mean value, friends, here? If you observe this point, and we are having the mean 500 hours, and I want to get greater than, means that one only, greater than 500 hours. Maybe this is up to 700 hours or whatever, never mind. Only our interest is, even he has taken 501 hours also okay, 700 hours also okay, but our interest is the members who got the chance of greater than 500 hours. That means
something like that. 0.3%, something like that.
Okay, so observe here.
0.1%.
What is this saying?
0.5.
How come? Because greater than 500 means, friends, how much? 99.7% of the data. Up to completely I can take.
Oh, okay,
completely
okay.
I
You
can
are
take.
taking completely. Okay.
If I am adding this one also, I could have get this 99.7%. Now my interest is only left side, right side, na? Greater than 500. What is that? 99.7 by 2. Almost that is 50%, na? 0.5. That's all. That's all. 0.5. Now on the same grounds, think through that. If I want to get some of the members like this, friends. $500 to $650. Mean value is 500. However, we are knowing that our interest is we need to compute the number of members who has taken 500 to 650 hours to complete the syllabus or to complete the training program.
So mean plus 1 standard deviation, 500 plus 100 is 100 hours.
Percentage, can you say the?
So it's difficult.
What is the standard deviation value we are having? 100. Now how many hours we are taking? 150. Okay, our normal standard deviation is 100, but we are taking how many hours, friends, here? 500 plus 150, na? Okay, 150 hours. So now if I am observing this kind of aspect, okay, what is the final value, friends? Suppose if I am asking you guys like this, 650 minus 500 by, what is the standard deviation value? 100. Can you compute the value, friends, for me? So this is 150 by 100, 15 by 10, which is 1.5. 1.5 means 1.5 standard deviation. 1.5 into the corresponding value, whatever the mean. Okay, so that means some 43% like that. Okay, so just you observe here, friend, the way we are understanding this particular thing is it's not observing the values, or it's not observing the percentage of data. Okay, the percentage of the data. That's what in the first thing we are having 99.7. The second standard deviation, standard deviation, that means 90. What is that value, friends? 95% actually. Almost, you know, if you are talking about this 1.5, okay, so just we are having 1.5 standard deviation, not 1.5 standard deviation, so that we are nearing to that two standard deviation, so that a slight differentiation, maybe 45, maybe the two standard deviation, because slightly we are moving from 1.5 to 2, we have taken this 43%, if you see. Now, if I am asking you the third question like this, suppose if any person want to take, okay, the third question, you know, range of 500 to 675. A simple, now you can able to calculate. What is the initial formula, friends? We have to take 675 minus 500 by, what is the standard deviation? 100. How many standard deviations? Okay, so this is 175 by 100. What is the value, friends? 1.75. That means how many standard deviations are having from mean? Almost near to 2 standard deviations. Okay, because 1.75 means in 2 standard deviations means what is the percentage? 95. That too, but we are only focusing on the positive value, not on the negative value. By 2, obviously we'll be getting the 45.9, something like that. Okay, so this is how you can refer the normal distribution. See how different it is from the other distributions. In case of the other distributions, we are having some kind of the restrictions, friends. Okay, that particular restriction always says that either the trial is single or else multiple trials we are having, though we are having success or failure. And in case of the uniform distribution, multiple trials would be there and equally likely kind of thing. But whereas in case of the normal distribution, there is a perfect narration, there is a perfect observation of both mean and as well as the standard deviation. And this particular thing is known as empirical rule. Your empirical rule. Okay, so the empirical rule says that suppose if your distribution is normal in nature and your 99.7% of the data lies within mu plus or minus 3 standard deviation, and if your 95% of the data lies between mu plus or minus 2 standard deviation, and your 68% of the data lies within mu plus or minus 1 standard deviation. Okay, now immediately one question you should ask me, friends. Okay, in case of the normal distribution, this is perfectly valid. 1 plus mu plus or minus standard deviation, mu plus or minus 2 standard deviation, mu plus or minus 3 standard deviation. Now you tell me, friends, can we expect always the normal distribution every time? Can we, friends?
Not, no.
May not. Okay, because so always I may not get the same kind of the, because the main important aspect with the normal distribution is our mean, median, and mode should be coincide. Okay, according to the calculations. What is the second important point? It is a symmetric. It must be symmetric in nature. Then only I can make use of this mu plus or minus 1 standard deviation, 2 standard deviation, or 3 standard deviation. Now for the tomorrow's aspect, what if I want to make use of, okay, if my distribution is not the normal distribution, non-normal distribution, then how do I compute the percentage of the data? Because my interest is now I am happy with the normal distribution, because it has opened one more avenue, like to understand the spread of the data, friends, which is not that much easy. Now I got some kind of the essence and the aspect, how do I fetch the data or how do I work out the data. So with the help of that normal distribution, I could able to observe that my distribution has span over to mu plus or minus 1 standard deviation, 2 or 3. Now what if my distribution is non-normal? Is there any use case is there, or is there any formula is there so as to observe the percentage of the data? Okay, so that we are going to see in the next session. Okay, now can someone help me, friends? Which are all the key takeaways? Definitely we have to revise the things, friends. Okay, first one,
Yep.
we have
For discrete data, we have seen Bernoulli and
discrete and continuous.
yes.
So for if you are
List.
observing the kind of the things, Bernoulli,
Which has only one trial.
one trial. Okay, very good. Which has success or failure. And what do you mean by binomial?
Binomial, which has
Series of Bernoulli.
And it has
Success or failure, same kind of thing. Only this is a single trial, friends. Okay, single trial. And what about the third one? Is the uniform distribution. Okay, this uniform distribution we have seen some formula, na? 1 by b minus a kind of thing. Is a kind of parameter based. Our last thing is normal distribution. Okay,
as Gaussian.
Gaussian normal. Yeah, Gaussian normal distribution. Yeah, if you see the normal distribution, friends, here mean, median,
mode should be
mode or similar, coincide. Okay, this is the first point, and symmetric kind of thing. And most importantly, we have seen some kind of the empirical rule.
empirical.
Okay, what do you mean by empirical rule? Okay, if your stat subject matter expert is asking about, hey, Suresh, have you applied the empirical rule? No, I cannot because my distribution is not normal. You can say that. Okay. So empirical, mean plus or minus one standard deviation. How much percentage of the data we are having, friends? That is very important. 68% of the data. Okay. And suppose if I'm talking about mean plus or minus 2 standard deviation, 95% of the data. And my third important thing is if I'm having 3 standard deviation, my 99.7% of the data lies within mean plus or minus 3 standard deviation. This empirical rule is also called as 3 sigma rule, or else you remember like this, friends. Okay, so 68, 95, 99% rule. Okay, both are one and same. Okay, so just you can remember like this: 68, 95, and 99.7%. Okay, so in the tomorrow session, okay, just I left with non-normal distribution. Is there any possibility of estimating the values? Maybe if I am not getting the normal distribution, what should I do? That discussion. And then I'm going to start with the very important and which is very easiest, the sampling techniques. More or less we are entering into the genre of machine learning. So almost I can say, and one more thing is I need to cover these statistical tests are there, friends. Like some test, I'll introduce you the Z-score, T-test, F-score, simple thing only. We are not going into all the implementations and all. After F-score, we are having chi-square.
These techniques, this mean plus standard deviation we have done in the Z-score, no?
What is the Z-score value?
Z-score. Yeah, the normalization standardization while discussion.
That is what. Okay, see, that is how we need to learn, friends, actually. So Suresh, you are very good, very correct, because in some of the examples, especially in case of the normal distribution, okay, you can apply your Z-score also, because we are knowing mean and that x value, and as well as the mean value, x value minus mu and standard deviation, so that we can find out the percentage. That also you can do that. Rather, see, you need not go into these 3 sigma rule or empirical rule kind of thing with Z-score.
3 sigma is very fundamental. Fundu way of finding is 3 sigma.
That's
3
all.
sigma, 2 sigma, and 1 sigma is really, it understands, the brain will understand clearly.
Clearly. But the alternative, that alternative for Z-score is, friends, this thing. Alternative of that thing is the Z-score. Okay. However, we are going to talk about the ANOVA model and chi-square, F-score, T-test, and Z-score. Just a glance of that. But we'll focus on these sampling techniques, friends. Maybe tomorrow, after completion of our non-normal distribution, the sampling techniques we are going to talk in between. So just that regression model is going to explain by our Suresh. Okay, that's all, guys. Okay. Thank you. Just to have a look on that and take some time to revise, because we are going to enter into the genre of machine learning only 2 or 3 days maximum more. And before 31st, I try to complete the stat and all the other kind of thing. From first onward, just we'll have a look on maybe third or first, second, or third. Will be starting our first machine learning algorithm implementation. Okay, so by that time, if I am asking you regression, or if I am asking you some kind of probability, you should be in a position to capture all these things in the understanding, because our 5 to 10 minutes or maximum 20 minutes is enough to explain the kind of data. Okay, that means implementation. Otherwise, all the things are normal. Okay, thank you, guys. Thank you very much. Bye.
Okay.
Bye bye.